We're going to go ahead and get started. We're going to, it's like the same as last time, about 3 pages, and then we'll be done. What we're going to talk about is how to experiment badly and a couple other things. So our online SAT prep course is effective. A high school regularly offers a review course to prepare students for the SAT. This year, budget cuts will allow the school to offer an online version of the course. Suppose the group of students who take the online course earn an average increase of 45 points in their math scores from a pre-test to the actual SAT test. Can we conclude that the online course is effective? So this experiment has a very simple design. A group of subjects, those subjects are the students, were exposed to a treatment, which was the online course, and the outcome, which is the score increase in math. Was observed, and then here's the design. So you're going to be designing experiments just like this. So students to online courses has an increase in math scores. So a closer look showed that many of the students in the online review course were taking advanced math classes in school. Maybe the students in the online course improved their math scores because of what they were learning in their school math classes, not because of the online course. This compounding prevents us from concluding that the online course is effective. So many lab experiments use a design like this one in the online SAT course example. So what they use is experimental treatments. Experimental units. I apologize. To treatments. To measure response. Experimental units to the treatments that they impose, and then measure their response. In the lab environment, simple designs often work well. Outside of the lab, badly designed experiments often yield worthless results because of compounding. Okay. So again, anytime that you run lab experiments like chemical lab experiments, you want to make sure that a lot of times you're in a controlled place. So labs are sanitized, and a lot of times you work under hoods, so it keeps all the germs and like any kind of debris out of your experiments. And you guys will probably do more of that once you get into college. Okay. To fix the above experiment, do a comparative experiment. Most well-designed experiments compare 2 or more treatments. Comparison alone isn't enough to produce results we can trust. If the treatments are given to groups that differ greatly when the experiment begins, bias will result. The solution to the problem of bias in sampling is random selection. In experiments, the solution is random assignment. So why do we randomly assign or randomly select? So it reduces bias. That's it. Do you have notes? No, I have to do reports. I think they're just set up there if you want to have it, so that way you can not have to worry about redoing it. Isn't it right there? Yeah. Okay, good. Sorry. Next time, just let me know. All right. In an experiment, random assign means that experimental units are assigned to treatments Using a chance process. What are the chance processes we've talked about?
Drawing from a hat.
Yep, what else? Oh, my computer is loud. What else? What are chance processes that we've used? He said drawing from a hat. What else? A random number generator. What else? One more. One more. Where else do we get random numbers from other than random number generator?
The table.
The table. Okay, I needed to go over those because you're about to talk about each one of those. All right, so flipping it over. How random assignment works. This year, the high school has had enough budget money to compare online SAT score, SAT course with a classroom SAT course. 50 students have agreed to participate in an experiment comparing the two instructional methods. Describe how you would randomly assign 25 students to each of the two methods. So there's all three of them using technology as the random number generator, okay? So how would you do this? First thing is you have 25 students, so make sure that you know that. We're gonna start with A. You said the first way was the hat method. When it asks you to do this, you have to be specific. Now, I keep getting homework that is kind of blah, like you just answer the question and you move on. You need to make sure you answer the question fully in the context of the problem. You will not get AP credit on the AP exam if you don't do that, okay? So if you just say the hat method, it's not gonna work. It wants you to describe it. So what would you do? How do you, literally, how do you do the hat method? What's the first thing you need to do? You're gonna write names. Now, hear me out for a minute. How many names do I have? No, 50. So make sure we started with 50 students, but we're choosing how many? 25. Write names on 50 slips of paper. Then what do? Before that? Put them in a hat. Be specific. What do? You guys just put them in there? There you go. Mix them. Sorry, I know it sounds crazy, but that's exactly what they want. They want whoever's reading this to be able to repeat your process. So you have to tell them exactly what you would do. And I ain't never seen nobody pull nothing out of a hat or out of a cup or anything like that without shaking it. Have y'all? That's it. So you're just mixing them up. Kind of like your deck of cards. You always shuffle them before you use them. Same thing. So mix them, then what? Do you draw all 25? Ooh. Wait a minute. Draw one at a time. What do you do with it? You put it back in there? No. So you say without replacement. Until we have what?
Are done.
Yep, are done. So until we have 25. What do you do with those 25? Why'd you draw them out? Why'd you pick those? But what are you doing to them? Why'd you pick 25? What are they going to do? Okay, well, how do I do that? These 25 take the online class. Others do not. That is a full random assignment. Now that you know this one, the other two will be easier, okay? Just because you need to know all the steps. All right, so B says using technology. So remember, if we use technology, it's a random number generator, so I can't put their names in. So what do I have to do? I can't put 50 numbers in my calculator. What do I got to do? What do you mean? What do you got to do first?
Assign each name a number.
Thank you. Assign students. You remember those hotels that we had to call? And we assigned them a number before we looked at it. So assign students to numbers, and you have to specify the numbers 1 through 50. So when we were doing the sunflower thing and there were 100, you would have to say whatever you chose, 00 to 99, or 101 to 00, with 00 being 100 or with 00 being 1. So you have to make sure that you tell that so that I know which one you're using where, okay? But this one, because it's a random number generator, not the table is the one where that matters. Because it's a random number generator, you can just use 1 and 50. That's perfectly fine, okay? So use random integer function. To choose what?
Like the sample.
Okay, but how many? What happened one time when we used our random integer, when we were like calling those hotels or whatever? What happens? Can we have repeats? No, the student can't take the course twice. So what do we got to make sure that we put in here? Choose 25 without repeats or non-repeating, whichever way you say it, as long as you can tell me that they don't repeat. Choose 25 non-repeating. Numbers. Perfect. What do they do? Mm-hmm. Others do not. Perfect. Table D is the crappiest one. Okay, and again, it always falls within how you write those numbers. Because if we have 1 to 50, I need 2-digit numbers. Okay, so you need to make sure that that reflects on there. That is the biggest thing that people miss, are those 2-digit numbers. So we're going to assign students. We have to give them a number, just like we did on the other. Either 0, 1 to 50. You could do 0, 0 to 49. I don't care. This one's easier, 0, 1 to 50. All right, how do you use table D? Where do we start?
Start at the left side and you just go in groups of 2.
Of where?
First, you have to choose like a column.
Does it, not a column, but a row? Does it matter which one? No. It says go to any line in table D. Now, if you're running your own experiment, you need to tell me what line. Go to line, blah, blah, blah. So like if you actually have a conclusion, how did you pick these 25? Name the 25 you picked. How did you pick them? You make sure you say, I went to line 6 and I did this, okay? So always specify. On this one, we're not trying to specify the actual 25, so they can choose them any way that they want to, okay? So go to any line in table D. What are we going to do?
Select the first 2 numbers, like, not select,
Got you? So read 2-digit numbers. And you have to be specific. So we're going from left to right, again, so that they can do your experiment. And what are we doing? Not seeing which one, what are we doing every single time? Choosing what? Choosing 25 what? Keep going. But what do we got to make sure they don't do? 25, non-repeating. Numbers. Make sure you put within the range. Why would I do that? I should have put that together. Sorry. Within the range. That should be one word. Sorry, I know that it's one word. Why does it have to be within the range?
You can't pick a student that doesn't exist.
Right. So the difference between this and the random generator, the random integer, is that that integer is only going to pick numbers 1 through 50, but your table is going to have more. So we don't want repeats and we don't want anything that's not in the range. That's what you're telling the person reading this. So make sure that you always put that as well. And then those 25 take online. All right, it's gonna get bigger. Okay, it'll get bigger. Everybody good? All right, random assignment should distribute the students taking advanced math classes in roughly equal numbers to each group. It should also balance out the number of students with lots of extracurricular activities and those with part-time jobs in the classroom and online SAT prep courses. Random assignment helps ensure that the effects of other variables are spread evenly among the two groups. Although random assignment should create two groups of students that are roughly equivalent, we still have to ensure that the only consistent difference between the groups during the experiment is the type of SAT prep that they would receive. We can control the effects of some variables by keeping them the same for both groups. So we'll talk about control later. We would not trust an experiment with just one student in each group. The results would depend too much on which group got lucky and received the stronger student. If we assign many subjects, that's important, a lot of them, to each group, however, the effects of chance will balance out. This is the idea of two groups unless the treatments themselves cause a difference. This again is the idea of, you need to know this. Replication. Use enough experimental units to distinguish the difference in the effect of the treatments. From chance variation due to the random assignment. And again, we'll talk about all of this again all together soon. All right, so principles of experimental design. You need to know these 4 principles. The first one is comparison. You're going to use a design that compares 2 or more treatments. You're going to use random assignment. You use chance to assign experimental units to treatments. Doing so helps create roughly equivalent groups of experimental units by balancing the effects of other variables among the treatment groups. You're going to need a control. Keep other variables that might affect this response the same for all groups. And then you're going to repeat it. It's a replication. Use enough experimental units in each group so that differences in the effects of the treatments can be distinguished from chance differences between the groups. These are real short. Why is control important in experiments? The first one is to prevent confounding. And the second is to reduce variability. In the response variable. All right, so this next page is really simple, but it's a long page. Not a lot of writing though. It's positive. Is everybody good here? All right. A well-designed experiment. Does regularly taking aspirin help protect people against heart attacks? The Physicians' Health Study looked at the effects of two drugs, aspirin and beta-carotene. Researchers wondered whether beta-carotene would help prevent some forms of cancer. The subjects in this experiment were 21,966 male physicians. There were two explanatory variables or factors, each having two levels, aspirin, yes or no, and beta-carotene, yes or no. Combinations of the levels of these factors from the four treatments are shown below. 1/4 of the subjects were assigned at random to each of these treatments. On odd number days, the subjects took either a tablet that contained aspirin or a dummy pill that looked and tasted like aspirin that had no active ingredient, which would be a placebo. On even numbered days, they took either a capsule containing beta-carotene or a placebo. There were several response variables. The study looked for heart attacks, several kinds of cancers, and other medical outcomes. After several years, 239 of the placebo group, but only 139 of the aspirin group had suffered heart attacks. This difference is large enough to give good evidence that taking aspirin does reduce heart attacks. It did not appear, however, that beta-carotene had any effect on preventing cancer. Okay, so there's just your treatments and the factor. So some of them got aspirin and beta-carotene. Some of them got aspirin but no beta-carotene. Some people got not aspirin but beta-carotene, blah, 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 whatever. Everybody got that? I saw that saying is the four treatments that were imposed. Explain how each of the four principles of experimental design was used in the study. So how did they compare? What did they compare?
If they were given the medication or not.
They compared both active treatments and placebo. So that's what they compared. Did the treatments compare to the placebos? How did they use random assignment? Should be the easiest one. It says it in the problem. How did they randomly assign? Guys, come on. Read the I just read it to you. Read the problem. Where does it talk about random assignment in the problem?
Oh, 1/4 would be given like the active and the non-active and whatever.
1/4 assigned to each treatment randomly, creating 4 equal groups. What did they control? Sometimes this is weird. There's a couple that you probably won't get. What did they control? What did they do consistently? Same dosage schedule. Everybody was on the same dosage schedule. Okay, so not only can you control like the treatments that you're given, but what are some other things that they controlled? That's that part. They all took the same thing, right? Pretty much. That dosage schedule. Nope.
Gender.
Yes, why?
Only males were used.
Okay, what else? One more thing, kind of in the same category. All physicians, same occupation. Why would that make a difference?
They all like have the same health knowledge.
Yeah, probably so. I would assume that that's what it is. So if they would have picked maybe some construction workers, they may not take care of themselves as well as a physician does. So they eliminated those compounding variables there and they picked somebody that had the same occupation, okay? And being in the healthcare, they might be more actively involved in taking those pills on a regular schedule, so on and so forth. All right, how'd they repeat it? Let me throw this out here too, because I'm going to go ahead and tell you this, and this is exactly the same in every single one of them. There were over 5,000 subjects per treatment. How did I get that?
20,000 something divided by the 4 treatments.
21,966 into 4 groups is 5491.5. And what does this do? It reduces or reducing variation. Okay, so any kind of replication is how many, basically how many subjects per treatment. Is everybody good? All right. This page is really quick, just fill in the blank, nothing crazy. Completely randomized designs. The design presents the details of the SAT prep experiment random assignment, the sizes of these groups and the treatment they receive and the response variables. There are statistical reasons for using treatment groups that are about equal in size. This type of design is, should say, called a completely randomized why can I not write today? Design. Random. Okay. So they had volunteer students, so 50 volunteer students. This is for the SAT. They randomly assigned them to 2 groups, 25 students and 25 students. You have to know how to do this because you are going to be making your own little chart soon, okay? The first group got the online, that's what you said. The second group got the classroom, and then they compared the results, the SAT scores, okay? In a completely randomized design, the experimental units are assigned to the treatments completely by chance. Notice that the definition of a completely randomized design does not require that each treatment be assigned to an equal number of experimental units. It does specify that the assignment of treatments must occur completely at random. We'll talk all about this soon, okay? Completely randomized designs can compare any number of treatments. On the next page is an experiment that compares 3 treatments. All right, this and check your understanding. We're done. I think I'm going to leave you to do the check your understanding and we'll go over it tomorrow, most likely. All right, completely randomized design. The check your understanding looks just like this, okay? Many utility companies have introduced programs to encourage conservation among their customers. An electric company considers placing small digital displays in a household to show current electricity use and what the cost would be if this use continued for a month. Will the displays reduce electricity use? One cheaper approach is to give customers a chart and information about monitoring their electricity use from the outside meter. Would this method work almost as well? The company decides to conduct an experiment to compare these 2 approaches, display or charts, with a group of customers who receive information about, Ben, come on now, energy consumption, but no help in monitoring electricity use. Describe a completely randomized design involving 60 single-family residences in the same city whose owners are willing to participate in such an experiment. Write a few sentences explaining how you would implement your design. So how many are we using? Who are our experimental units?
60 single-family residences.
And I just put houses, but single family residences is fine. I'm gonna make this a little bit bigger so you guys can see it. What are you gonna do to those 60 houses? What are you gonna do to them? Think back to our other one. We had 50 students. What did we do to those 50 students?
Randomly assign them a display or chart.
Randomly assigned. So we just write random assign. And their only choices were online or class, right? Online or in person. What are our choices for these guys? Okay, well, what else? Remember, we did online versus regular because our regular was our control, right? We were just trying to see if online was better. So we used our regular classroom as our control. Do you have a control in here yet? How many treatments did we impose? 2. We need a control. So we actually need to randomly assign them to 3 groups. Your first group your second group, and your third group. My question is, how many in each group? That's what you need to write now. 60 houses, how many in each group?
20.
N equals 20. Tell me what group 1's going to do. I'm going to abbreviate treatment just because I'm running out of room. That is perfectly fine. They can be your control group. So they don't do anything. Does everybody understand that? They keep everything normal like they have been. Okay. What about treatment 2? What's the second one going to get? Come on, guys. What are they going to get? What?
Display.
Display. And treatment 3.
Chart.
Good. Guys, this can come in any order, okay? It doesn't matter. Treatment 1 could be treatment 3 or whatever. That's not a big deal. What do you do after you give them all the treatments?
Compare their energy use.
Yes. And all you have to put is compare results. Your design should be made up this way every single time. It says, write a few sentences explaining how you would implement your design. So you're just writing about this design. So how would you randomly assign 60 houses? You can pick either of the 3 methods. I'm going to pick the hat method just because you guys are really good at that. It's really easy. So label slips of paper. One through 60 to represent houses. What would you do then? I labeled, what do I do after I label them if I'm doing the hat method? And do what? And mix. What do I do now? Without? Not repeating, but we don't put them back in without replacement. Now, if you're doing the number stuff and the table stuff, yes, without repeating. So without replacement, these 20 what? Let's say these 20 get displaced. Draw 20 more. Without replacement. These get charts. The remaining 20 are the control. So we did the 60 houses, we randomly assigned, we put them into groups, we treated them. What's the last thing we need to do? We did everything but what? Compare the results. So at the end, compare electricity usage. That's it. So once you draw it, just write what you do. And the random assignment is the worst part of that, okay? Why did we include a control group of 20 houses? Because the main purpose of the control group is to provide a baseline for comparing. All right, so it's about to cut off. I am done. Do the check your understanding. I'm going to go over it first thing tomorrow, and then you do your quiz. Okay, check your understanding. I want you to try that on your own. It's just like this. And then, like I said, you guys can go ahead and go do your quiz. Give me a minute.